Hey everybody, this is Alex Merced from alexmercedcoder.com, and welcome to day 13 of our 100 days of Go and Rust. And today's going to be a quick one. Today we're just going to learn how to use environmental variables in Go and Rust. Okay, what are environmental variables? Environmental variables are variables that don't exist in your code. They are defined in your operating system. So typically if you're using the bash terminal, which you probably are if you're using Mac or Linux, or if you're using the Git bash software or the Ubuntu Windows subsystem for Linux, in Windows you can also access the bash terminal. Essentially what you would do is you just define variables. So I would just say like export cheese equals, or let's just say cheese equals Gouda. Okay. So now if I were to say echo $cheese, I get Gouda. So within this terminal, so it's not in all my terminals, within this particular terminal instance, a variable exists called cheese that I can actually access from any scripts I run within that terminal context. You could create variables that persist. You would have to define them in your configuration files, or you could use some sort of third-party library like a .env library that defines those variables whenever you run a script. But for now, we'll stick to this. So the idea is that I can find this variable that exists in my operating system, specifically in this shell environment. So if I open up another shell, so let me do that. If I open up another shell and I say echo $cheese, see, I get nothing. But in this terminal, if I do echo $cheese, I still get Gouda because the variable is defined in the memory of that process. Okay, so if you didn't see my previous video, non-Go, non-Rust, where I went through using environmental variables in Python, Django, Python, Ruby, JavaScript in Node and Deno, and a few other languages, that's worth watching because I do a much deeper dive on what is environmental variables there. But how do I access those variables in these languages? Every language has a way to access those variables within the context that, in this case, in the context that the code is being compiled in, because it's going to pull those variables at compile time instead of pulling them at runtime like the interpreted languages. So in Go, it's pretty straightforward. I'm going to replace this errors library with OS. So I'm going to use the OS library. Actually, I should just probably comment that out in case I need it later. So comment that out. And what I want to do is use a library called OS. And let me just clear out all this stuff from the error handling episode. Okay, and essentially, there's two functions in two main functions we want to deal with right now. So that's going to be OS either get env, which is going to be what gets us the variable. So in this case, I want to get cheese. So I would just say cheese equals that, and then I can fmt.println cheese. And then that's it. This should all run. So let me open up a terminal in that for Go. Let me redefine that variable, cheese equals Gouda, because it's a different environment or different shell instance. And let's do it. Go run.go. And it prints Gouda. Okay, so notice I never wrote Gouda anywhere in my script, nor did I ever define a variable called, I defined a variable called cheese, but I never wrote Gouda anywhere. But it went to get this environmental variable called cheese. It checks the operating system environment that it's currently running, the shell context that it's currently running in, to see if there's any variables in this environment. Because at the end of the day, like, any program you run is essentially a sub-function. Like, everything's a function. So your operating system is essentially a giant function that's just running as long as your computer's on. So then your shell is essentially a sub-function that's running within that. So it's within the operating system's scope. So your program, so in this case the compiler or the interpreter that you're running to interpret your code or compile your code, is a sub-function of that. So if you imagine the stack, you'll have the operating system, the shell, and then your program, or the thing that's interpreting or compiling your code. So just kind of like you would in your own program, the subfunction has access to the parent function scope. Okay, so in this case, because of where our program is on the stack, it has access to all the variables of the shell that it's stacked on top of. Okay, I'm not sure if that's 100% correct, but I think that thinking about it that way will help you understand, helps clarify like why can I use environmental variables, and generally like how am I accessing them? Because technically your program is running within the scope of the shell system, so there's access to those variables within that scope. Okay, so pretty sure, and if I wanted to set variables, I could do that too. So I could be like os.set env, and then I can set a variable, but that's less useful, because usually the point of environmental variables is to not explicitly say variables in your code. So usually you're trying to get environmental variables and you're trying to define them somewhere other than in your code, whether it's in line in the script, because I could actually just define it when I write the script. So I could say something like cheese equals rye, and then do go run.go, and then I define it for that one execution. So the minute this command is done running, it goes back to being Gouda. Okay, so I just did that, and then if I do echo cheese, see, it's still Gouda. So I can, if I export it like I did up here, it sets it for the entirety or for the remainder of that shell instance. But if I define it in line with another command, then it just has it defined for that one command. And then again, if I were to define it in like my bashrc file or zushrc file, that configuration file for that particular shell environment, then it becomes persistent, will kind of always be there. Okay, cool. So that's how you do it in Go. Okay. Now in Rust, let me just clear all this out. Let's delete that. I'm gonna comment out this. Delete that. And then I think with use standard, I think it's env. What is it? env. Already escaped my brain already. Rust, environmental variables. It's env or something. Yeah, they're standard at env. Okay, right here. Okay, cool. Okay. Okay. And the function then is going to be, oh my god, I already forgot the function. But it was, you can see here, structs, enum functions. Var os, set var, args home, set var sets an environmental variable k to the value v, fetches environmental variable key from the current process, fetches environmental key from the current process, returning none if the variable isn't set. And I think that's the one we're going to want to use, because that one returns a, let's go over here, see, it returns an option, which means it may be something, it may be not. And I think the original one returns a result, if I remember correctly. Yeah, it returns a result. Okay. So I could do this. But technically I just want to, I'll just leave it, env. Okay. So then I will declare variable, so let cheese equal env vars. And then I'll say I want the cheese variable. And theoretically, here's where I could use the question mark, because it returns a result. Again, the difference is vars os returns an option, which means it may be something, it may be nothing, or maybe something. The difference is, if I use vars, it's a result, so it might return an error. So instead of returning nothing, which doesn't trigger an error, it's just nothing, the result, it returns you the thing or an error. So results always return you the thing or an error. An option always returns you the thing or nothing. But again, not an error. Okay, so technically what this does, it'll just check for the error, and if there's no error, then it'll assign to that. And then I should just be able to be like, print line cheese. And technically this should all kind of work. Okay, so we'll try that out first. I'll show you a couple different ways we can handle this. Okay, let's open up a terminal for Rust. Open and integrate a terminal. Okay, and Rust. Well, first let's export the variable. Export cheese equals Gouda. And then we're going to compile it. Rust C run.rs. And then we want to run the compile file. /run. Okay, we got an error. Let's see what the error is. Can I function that returns okie dokie. So in that case, there's a couple of things we could do. Now, technically, when you return a result, you could also use this expect function. Okay, and the idea is that you expect a value, and then if you don't have it, you return a message. So no variable here. Okay. Typically, this is not the way we're going to want to do this, but I'm just going to show you that you can do it. Not found in Vars. Let's take a look at the example here. And it is returning a result, but I guess it doesn't want to do that. Okay, I'll just stick to what I was looking at earlier. Is error. Okay, so basically what this does, it just checks, is the return result an error? If the return result an error, then, you know, it's an error. Otherwise, it's just going to let me assign the thing. Oops, doesn't like that. Method not found in Vars. Notice it says uppercase Vars. This function takes 0 arguments, but 1 argument was supplied. Oh, okay, let me see here. Am I using the right argument? Function var. Yeah, it now takes the key. And var key. That's the way I use it. And oh, I wrote vars. And this is var. What does vars do? Vars. Yeah, this takes no arguments, returns an iterator pair of strings of all the environmental variables. That's if I want all of them. Okay, got it. Okay, so yeah, my bad. Var. So technically, that's why that wasn't working. So let's try this again. Okay, can I use it? Still says it's returning, let's see, restrict trait. Var error. Okie dokie. And let's try dot expect. Just out of curiosity. Expected one argument. Oh yeah, expect second message. Hello. Okay, see that works. Okay, again, whenever you return a result, you could always use expect. Now, yeah. And then what expect does is just basically says, it expects there to be a response. If not, then hello. So if I do something like, let's take a look for a different variable, boo, which I didn't define. Let's see what happens. Okay. Panicked at hello, not present. Okay. Thread main panic at hello, not present. Okay, and see again, that's the error, not present. Okay. The problem with expect, I think it panics. Yeah, that's the right. When you do expect, it either has the value or it panics, meaning it shuts down the program if it's not there. The other one, I keep forgetting what the other one is. I want to say it's okay. So I think it's like, okay. Cheese cannot be formatted with a default formatter. Yeah, so you see here, it just goes forward. So basically, if you have a result, you can use this okay function, and if there's an error, it just lets the thing move forward, but you see now the error is unhandled. So when I try to log, so now the error is saved in cheese. So, which I could do this for, I think errors, they have debugs on them. Yep, and you see like I have this error of type none, or error with none inside of it. because errors are like tuple structs. And the same way like okays are tuple structs. So you see I'm receiving like this error. The other thing I could do is I could match it. I could do a match. I'm not going to do that. Well, maybe we'll do that in a second. And then there's also is error, which seems to be sort of the preferred method for environmental variables. And what this will do, okay, and see it'll return true if there is an error. And let's see what happens if it's not an error. So let's try to go back to cheese. I get false. So in that case, so that just gives me back a Boolean. So I'd have to still check. But those are the couple possibilities you can chain off with the result. The other thing you can always do is do a match instead. So I can say match environmental variable cheese. And again, that's either going to be okay with the value. In which case we want to print line. We want to do a print line with one of these because it's just a scalar value. And then there is error, the value of the error, and then this here we would want to do print line, and do this, and do one of these because it's something that I have to use debug for. So whenever like most structs, if they want to be printed, that you need to implement a trait called debug. And debug means I can then use this, and it'll say, hey, print the thing. I can be like, hey, print cheese if it's an error, or actually in this case, E. Okay, let me get rid of this line. And again, I can use pattern matching, saying, hey, is it an okay tuple? If it is, the value is in the variable called value. If it's an error tuple, then do that. And this should work. Yep, Gouda. Again, if I change this to boo, which doesn't exist. Okay, not present. So I'm getting back the error. Okay, so again, just a little bit more about working with results, because we did talk about results last time. Okay, I'm not sure why the question operator is always so finicky with me, because it says like it returns result, but you have okay. Okay, will just ignore the error situation. Expect will allow you to panic, basically shut down the program if there's an error. And then there is, you don't have to do a match. Well, you can always pattern match it. You can do is error, just see true or false. What the thing returns, if that's all you care about. And things like that. So that's how you use environmental variables in Rust. This is how you use environmental variables in Go. So my name is Alex Merced from alexmercedcoder.com. Do subscribe to the channel, hit that like button, and follow me on Twitter at alexmercedcoder. Same thing on Instagram, and like me and go connect with me on LinkedIn. I'll see you all later, and join the Slack and Discord communities over there at devnursery.com, and keep watching. See you all later.